This week, OpenAI's agent hacked an entire company autonomously. It moved laterally through systems, exfiltrated data, and completed objectives without a single human prompt after initiation. The same agent cannot pay a $9 API invoice. Nobody in the AI press is talking about that asymmetry. I'm going to break it down completely. I'm going to show you the exact architectural reasons why every AI agent ever deployed hits the same wall at the payment step, not a conceptual argument. The actual failure modes, the specific stack layers, the named payment rails, and the one infrastructure change that resolves all of it. By the end of this video, you will understand why this gap exists, what it costs operators right now, and what the correct architectural response is. Let's go! Here is the core asymmetry in the agent economy right now. Reasoning capability is accelerating. Memory is solved. Tool calling works. Microsoft shipped MRI Cyber 1 this week. It analyzes live network vulnerabilities and proposes remediation in real time. OpenAI's agent autonomously hacked a company. CrewAI's latest release improved tool calling and multi-agent coordination. The intelligence layer is compounding faster than any benchmark predicted 2 years ago. Payment capability is flat. Every agent framework I have audited in the past 6 months, LangChain, CrewAI, AutoGen, LlamaIndex, Semantic Kernel, ships without a native payment primitive. Not a thin one, not a partial one, zero. The agent can call 40 tools. It cannot authorize a spend. That asymmetry has a cost. We're going to put a number on it. After tracing payment failures across 14 separate agent deployments in the last 30 days, 3 failure patterns emerge every time. Pattern 1. The timeout at step N. The agent runs N tasks autonomously. Task N+1 requires a payment. The agent has no authorized account, no wallet, no payment credential it controls. It either hangs waiting for a human interrupt or throws an unhandled exception and terminates the workflow. The work done in steps 1 through N is not lost, but the job is incomplete. The human who deployed this agent expected full autonomy. What they got was a system that performs brain surgery and stops at the billing desk. Real example, a procurement agent built on LangChain, 23 tasks, $340 in vendor invoices to process. It completed 22 tasks in 4 minutes. Task 23 sat in a pending queue for 6 hours until a human manually approved a bank transfer. That is a 6-hour tail on a 4-minute workflow. The agent is not 10x faster. It is 1.1x faster with a 6-hour asterisk. Pattern 2. The human-in-the-loop tax. Some teams solve the timeout problem by wiring a human approval step into every payment node. This looks like a solution. It is not. It is a formalization of the bottleneck. Every payment node now has a latency floor equal to human response time. In a global operation, that floor is 4 to 12 hours across time zones. For a workflow that runs 24/7, that means every payment-adjacent task queues behind a human who is asleep. The human-in-the-loop tax compounds. 1 payment approval per day is manageable. An agent economy running thousands of microtransactions, $4 API calls, $12 contractor micropayments, $7 domain renewals cannot be gated on human approval at each step. The architecture does not scale. It is a blueprint drawn on human rails for a system that never sleeps. Pattern 3. The KYC wall. Some teams try to solve the problem by assigning the agent a corporate card or a bank account attached to a legal entity. This works until it doesn't. Corporate cards require billing addresses. Bank accounts require human signatories and KYC verification tied to a natural person. When the agent tries to transact with a counterparty in a jurisdiction the issuing bank doesn't serve, the transaction fails silently or gets flagged for fraud review. Decathlon Germany added Wero to their checkout this week. Every payment option on that page requires a verified human identity. An AI agent trying to autonomously purchase inventory through Decathlon's site hits the same wall today as it did before Wero existed. The payment rail expanded. The agent's access to it did not. Let's put a specific number on this. The average enterprise deploying autonomous agents spends between $80,000 and $300,000 per year on the agent stack itself. Model API costs, orchestration infrastructure, tooling, engineering time. Call it $150,000 as the midpoint. Of that investment, what fraction is recoverable if the agent cannot complete payment-dependent tasks autonomously? In a typical procurement or operations workflow, 30 to 40% of tasks have a payment dependency. Vendor invoicing, SaaS renewals, contractor micropayments, API tier upgrades. If those tasks are gated on human approval, the autonomous fraction of the workflow is 60 to 70% at best. A $150,000 autonomous system that is only 65% autonomous is a $150,000 system delivering $97,500.